Hello everyone, myself Ranjit Kesi, working as an assistant professor at Department of CSE, MIT Mysore. In today's session, we will discuss about weight functions, the different forms of an weight function. So it is very clear that with the help of a fork function, we can able to create a new process. Any currently running process that executes a function called fork, it will create a new process. And when this particular process has been terminated, say whether the process has been terminated in a safe mode or in unsafe mode, in both the cases, that terminated process termination status will be generated. That termination status is nothing but the documentation of that particular process. So this document will contain the piece of information about the existence of that process. So what are the different process it has been done when during its existence. So that is what the information that will be stored in the termination status, and what is the reason for the termination of an process, and what are the different files accessed by it, and what are the different read and write operation done by that process will be documented in this file called a termination status file. So this termination status should be retrieved by the parent process. If not the case, that process will become a zombie process. A zombie is a state in which the process is been terminated, but its termination status is not been written by its parent process. So such a case we call it as a zombie process. So it is very essential that any parent process, its child process, termination status should be written by it. Other way around, it will become a zombie. So how to avoid a zombie? It is with the help of a function called wait functions. So wait is a function with the help of which the termination status of a terminated process can be retrieved by its parent process. That is what the use of a wait function. Here in this particular syllabus, it has been given with 4 different forms of an wait functions. We will learn in detail about the different forms of an wait function. So for the very first one is the wait function. Next one is an wait PID. Next is an wait 3 and wait 4. So these are the different forms of an wait functions which has been used to retrieve termination status of a terminated process. So all these particular APIs has been exclusively used for retrieving of termination status of an terminated process itself. But all these particular APIs has its own common feature which will be provided for an user for its applicability. So based upon that, a suitable API will be used for the dedicated purpose. So let us know what exactly the details of these 4 different forms of an wait functions are. These are the function prototype of wait and Waitpid function. So wait and Waitpid function, its prototype is something like this, where exactly wait function will take a 1 argument and wait PID function will take a 3 different arguments. So before going to the detail of this different wait forms, let me just take up an example to illustrate about usage of this wait functions. So for this case, I will consider process which has been executed fork function thrice. So when the parent process, the current learning process executes a function called fork, it will create a new child process, and the newly created child process, this fork function will return 0 to the child process and PD to its parent process. That same thing will happen for all the three different processes. In this particular case, let me consider if this particular child process hasn't been terminated. For example, in this particular case, P1, P2, P3 are considered to be the child process of a parent process called P. So here exactly all this particular P1, P2, P3 are still in execution and not been terminated. If that is so true, if a function, if a parent process invokes a function called wait function, at that instance what exactly happens? So when a wait function has been executed at that instance, the termination status of there will be no process that will be terminated basically, because of which the wait function will be blocked for its execution. Mean to say, the termination status will not be returned to the caller process. The reason is there is no terminated process still. So at that instance, the caller process, the wait function will wait until unless some other particular child process get terminated first, then its terminated status will be returned to its caller process. That is the best example for a wait function. Suppose if I want the execution or retrieval of a termination status not to be waited for the child process termination, at that instance we can make use of the second variant, that is the wait PID function, where exactly we can avoid a case of the blocking mode of execution. That is the better usage of the wait PID function, where in case of a wait function, if a current learning process has been executed a wait function and no other particular child process has been terminated, at that instance it will wait until unless any one of the child process get terminated for its process. If not the case, the wait function will wait until unless the child to terminate, where in case of an wait PD function we can able to control the blocking mode of an execution, where exactly if there is no terminated child process, the control will be returned directly back to the parent process, saying that there is no process that has been terminated, and hence it cannot retrieve termination status. And then if let me consider another case where exactly all the three different child processes are being terminated. Okay, all three different child processes are being terminated. At that instance, if a wait function has been executed, let me consider P1 has been terminated first and P2 and P3. If this is the order in which the process has been terminated, and if wait function has been called, it will return the termination status of a terminated process which has been terminated to the first. That is, which process which has been terminated first, its termination status will be returned to the parent process. So that is the usage of the wait function, where exactly wait is a function which will return a termination status of the process which has been terminated first. It doesn't care for the different process that has been terminated. So any one execution of an wait function, it will return the termination status of any one process, and that process will be the process which has been terminated first. It doesn't care about the rest of the different process, even if it has been terminated. If this is the case, and if my expectation is, if the user expectation is, it wants to retrieve the termination status of a third process, that is then P3. At that instance, what actually it will do is, it will execute a wait function. At that instance, it will return the termination status of a first terminated process, and it will check whether this is the termination status it is looking forward. If not the case, it will ignore the termination status, execute the same wait function once again. It will get the termination status of an P2, and it will check whether this is the termination status it has been required. If it has been not, it will ignore even this particular termination status, and once again we need to execute a wait function to retrieve the termination state of a third terminated child process. So here you can observe, if there is no control on retrieving of a particular child process which has been terminated, So mean to say, think about there are thousands number of child process. At that instance, if I really want to retrieve termination status of 500 child process, at that instance I need to execute that wait function for that amount of times. Okay, because there is no exclusive control of on wait function to retrieve termination status of a particular process, and hence we need to keep on doing this particular job on an iterative basis and keep on checking whether the retrieve termination status is the required one or not. If it is not, we need to ignore and execute the wait function once again. That is the major flaw with the wait function. That is, wait function will execute in such a way that it will fetch or return the termination status of a first terminated child process. Okay, where in case of an Waitpid function, we can able to retrieve termination status of a particular process, because in the argument list we can able to specify the process ID. So which particular process we are interested to know its termination status, we can mention that particular process ID directly. So that is the major difference between wait and Waitpid functions. So in your main exams as well as another competitive exams, you will get these sort of questions on the process aspects, that is the creation of a process, termination of a process, and signaling. All these are very important topics to be remembered for over the years, and care must be taken to distinguish between the different forms of an wait functions and different forms of an fork and different forms of an exec functions. Okay, so let me just come back to this wait functions again. This wait function takes only one argument, that is the pointers towards the stat location. So where exactly this actually contains the address in which the termination status, its address is being stored. For example, if I consider process P1 has been terminated, its termination status will be generated by the kernel. Its termination status will be generated, it will be stored in a Unix file system, and that address will be returned back to the calling process. That is what the wait function it actually works. Okay, it will return the address in which the termination status is actually been stored. Where in case of an Waitpid function, it actually takes three different arguments. The very first one is an PID, with the help of which you can able to point out the particular child process for which the termination status is been required to retrieve. Okay, then the second one is once again the address in which the termination status is being stored. And the last one is an options, with the help of which this is the last argument called options, with the help of which you can able to control the working of an Waitpid function. Suppose if you really want the execution not to work in an blocking mode of execution, we can able to specify the different possible values for that options argument. That is how we can have a more control on the way in which Waitpid function will work. So this is the clarity on wait functions, that is wait and Waitpid. That wait 3 and wait 4 is not a much difference. Only thing is it is having one more extra argument which will be taken up after. Suppose if we consider a case where exactly the parent process, it is having a 3 different child process, and all the 3 different child process are not been terminated. At that instance, if a parent process executes a function called wait, at that instance it will report an error saying that there is no termination status to retrieve, and hence the failure of execution can be observed, or else it will enter into the blocking mode of an execution, which can be avoided with the help of the Waitpid function by specifying the appropriate options. And you can observe that the return value for both wait and Waitpid function is the same, that is PID, that is a process identifier. So which will actually return the process identifier of the termination status that has been belonging to. So it will return the PID of termination status of its process. So that is the return value of this. It will return the PID of a terminated status on a successful execution. It will return a -1 for all its failure of execution. Coming back to this termination status, what exactly a termination status will actually contain is, it is contain the bits of information it contains the bits of information. That bits will actually specify the details about the process in which it has been terminated. So this information is very crucial, which will actually give the details for its parent process. It will specify the way in which this child process has been terminated, whether it has been safely terminated or abnormal termination, and if it is an abnormal termination, which is the signal that caused its termination. All this piece of information will be stored in this particular termination status, which will be returned by its parent process. And to specify this, there exists set of macros that are being used, which will be present in a termination status, which will be used to identify the state in which the process is being terminated. And these sort of macros are listed as something like this. These are the different macros that actually will be present, that will be stored in a termination status, which we can able to use for knowing the status in which the process has been terminated. The very first one is WF exited. Suppose if this bit is been set to be 1, it means to say that the process is been safely terminated. That safely terminate, if any process is been terminated safely by using a different possible values that has been discussed in a previous session, at that instance this bit will be turned to be 1. So which we can able to understand that the this particular process, the terminated process, has been terminated because in the mode of an safe termination. The second one is an signal, WAF signal. So if this particular bit is set to be 1, it means to say that the process has been terminated because of some external signals. So even the signals are being used to terminate any particular process, and if any process has been terminated due to signals, at that instance this particular bit will be set to be 1, with the help of which we can able to understand that the reason for termination of this process is an abnormal mode of termination, and that abnormality is because of an signal. So at that instance we can able to fetch an appropriate signal which has caused the termination of this particular process. And the next one is an WAF stopped, where exactly this, if this bit is been set to be 1, it means to say that that process is been stopped by its execution due to some other request. So if any process has been stopped due to some other request, at that instance this bit will be turned to be 1, because it doesn't mean that whenever a process has been terminated, only at that instance the termination status will be generated. Okay, as when a process has been created, its actually documentation will be done. It is very similar to you people. When you just enter into the college, your ledger will be created, isn't it? It will keep, it can be used for keeping track of your fee payments, your academics, your results, all these things, isn't it? So as and when the things are being done, it will be updated over there, with the help of which that particular piece of document can be used in later part to know about that particular student, isn't it? Like that same, this document is being used to know about the terminated process. It will be something like your people taking a TC, where exactly at that instance in that particular form it will be mentioned very clear whether this student has been successfully graduated or been discontinued, or all this particular information can be find out in that document, right? That is how the termination status will also have the sense of information about a process. Okay, and this bit will be termed only when the process has been stopped due to some other request. At that instance this bit will be set to be 1. And the last macro is, that is a WAF continued. So this bit will be set to be 1 only when any particular process that was been stopped to different request and been continued for its execution. in the job control mechanism, in the way in which the process has been given a chance to execute, at that instance if a process has been continued to execute, this bit will be turned to be 1. That is what this macro stands for. Coming back to this, the last argument, that is an options, with the help of which we can have a more control on the way in which wait function works. We can also specify 3 more macros for this options. That is the third argument of an Waitpid function, that is W continued, W no ang, W untraced. What actually this particular W continued specifies is, if that particular process need to be terminated for some reason, at that instance we can mention this particular macro that actually specify the process was been stopped and been continued based upon its job allocation mechanism. And if this particular macro has been set, that is W no ang, mean to say that if the requested process has not been terminated, at that instance without waiting for that particular process termination, the control will be returned back to the calling process. That is how the non-blocking mode of a feature of an Waitpid function can be explored. And last one is W untraced. What actually this W untraced specify is, if a process has been terminated but its termination status is not been able to retrieve properly, at that instance this particular piece of macro will specify the termination status. It cannot be found for the terminated process. That is what this constant is all about. So these are the discussion about the wait and Waitpid function, with the help of which termination status of a terminated process can be retrieved by its parent process. And make sure that this wait function can be called by a parent process and not by a child process. If a child process has some more particular child process, at that instance it can call this wait function. Other around, it will report an error stating that the wait function cannot be executed. Now let us know more on what is the wait 3 and wait 4 is all about, and how exactly wait 3 and wait 4 differs from wait and then Waitpid functions. These are the 2 more variants of an wait function, that is an wait 3 and wait 4. So wait 3 is very similar to wait function, wait form, and wait 4 is very similar to Waitpid function, but only difference is these 2 different function as an extra arguments which will actually specify one more argument that will actually gives the information about the resources used by that process during its existence. So these wait 3 and wait 4 as an one more extra argument, that is an the structure called R usage. Its address will be mentioned over here, where exactly it will give the details about the different resources used by that process during its existence. That resources may be the different files that are being used, and different write calls, different read calls that is made by the process when the different files existed, and different signals generated by the process. That is about the resources. The resource usage of that process will be tracked by the help of this argument. So this is nothing but the added information to the termination status, which will also specify the different resources used by that terminated process during its existence. That is the only difference with respect to Waitpid and wait 3 and then wait 4. So the return value is also same, that is it will return a process identifier of a terminated process. That is about the wait 3 and then wait 4 forms of an wait functions. The next topic to be discussed is a race condition. So we will know what exactly a race condition is, and we will also know about how to avoid a race condition with an appropriate example. So first and foremost, let us know what exactly a race condition is. To explain this, let me take up an example, that is, let me consider a file called F1, and let me think about that 2 different processes called P1 and P2. And both this process P1 and P2 are accessing the same file called F1, and this particular process are access this file called F1 in terms of an write mode. Write mode in the sense both this particular process called P1 and P2 are trying to write some information to this file called F1. So at that instance, what exactly happens is, so race condition is a state in which two or more number of a process are trying to do some operation on a same common file or a common shared file. At that instance, the order in which the data has been stored will be deferred. That is what a case about a race condition. That is, if two different processes are trying to write some information to a same common file, at that instance the output will be based upon the order in which process P1 and process P2 is being executed, because it is very clear. So if there are more number of process, so there existence schedulers, that is a scheduling algorithm which will actually manages the order in which the process to be executed. At that instance, the content or the information that will be stored in the file will depend upon the order in which the process is being executed. So even you people might have been experienced this. That is, when you really want to communicate with your friend sitting next to you, and if you just share a last sheet of your notebook to pass on some information, at that instance the information written on the sheet of a paper will actually depend upon the way in which it has been written, isn't it? That is, if a first person has been written some information, then the chance given to the second person, the second person can able to know what is actually the information very clearly. Other way around, if both the people started writing on it, definitely the data will be intermixed, isn't it? That leads to the confusion, that leads to an ambiguity with the data present in a file or a document, and hence there requires a synchronization between the process. That is, let the process P1 completes its task and then chance given to the second process, or else let the second process completes its task first and then the first process. If not the case, there exists an ambiguity with the data present, and this leads to a lot of different problems later part. And hence this entire consequence is termed to be a race condition. That is, race condition is defined like if two or more number of a process trying to do some operation with a common file, for instance the final outcome will depend upon the order in which the process is being executed. That is what the common definition for a race condition. And to avoid a race condition, it is all it requires is we need to schedule the process such a way that there will be no ambiguity between the execution of that process. So we will know in detail about with some example, that is how to what exactly a race condition state is and how to avoid a race condition. In your main exam, you will be asked something like define a race condition and give a code snippet which will represent a race condition, and you may also be asked to explain about a avoidance of a race condition. At that instance, you need to write the definition, then small representation of that which will depict that case, and followed by you need to write a small code snippet that will represent the state of a race condition. And also, if it has been asked for an avoidance of a race condition, even that particular part of a code needs to be written, and it is very important topic to be studied for your exam point of view same time. So let me just explain this particular piece of code, and it is very clear that apu.h is not any other existing header file. It is said to be the user defined header file, which will have all different header files as mentioned in your given textbook. So here we have been created a user defined function called carry time. Then the main function, here we have created a variable called PID of type PID_t. This is said to be the data type, which will have a process identifiers. Then here we have been made use of a fork function to create a new child process. So fork is a function which is being used to create a new child process, and if that value is less than 0, it is said to be the fork error. Okay, and if the fork is not the return value of fork is not less than 0, at that instance it could be either parent process or a child process, that is the currently running process. To know that we have been made use of this, that is the condition process identifier is 0. If the currently running process identifier is 0, it means to say that it is an child process. So here we are actually trying to print a statement called output from child process, and if not, that is it is said to be a parent process and trying to print a statement called output from parent process. Then we have been made use of these two different processes are trying to print this set of information to the common standard output. At that instance, anyhow both the process parent and child process will actually execute the same set of instructions, and that instance both the process will get a chance to execute. When they have been given a chance, definitely they will try to print both this information, isn't it? At that instance, if it is trying to write out to a common file, or here in this case we have been made use of a standard output, and the standard output, the content will be intermixed. Reason is, for example, for 2 time slice, if a parent process has been allowed to execute, it will try to print appropriate set of information and followed by the child process. That is how things will actually happen. To make that as more evident, we have made use of an character time function where exactly only one particular character is trying to print at that instance. So with the help of which we can able to clearly distinguish the execution of the parent process and then the child process. Here both the parent process and child process compete between each other to execute this set of information. So that is how we have been trying to represent the case of an race condition, because race conditions is in the sense it requires at least 2 or more number of process, and hence we have been created a fork function to create a new child process, and both the parent and child process are competing amongst each other, and hence it is said to be a state of an race condition, and that is what the race condition is with respect to this example. Then how to avoid the race condition? That is, if the currently running process is a child process, I can simply say as wait parent. If the currently running process is a child process, I need to make the parent process to wait, and if the currently running process is a parent process, I need to make the child process to wait. That is how I can able to synchronize both the parent as well as child process, so that the data will not be intermixed between its execution cycles. So here there existed 2 different functions, that is an wait parent and wait child. So with the help of which we can able to synchronize or control the execution of an parent or else an child process. So here we have been made use of an wait parent, and here we make use of a function called wait child. That is, if the currently running process is a parent process, what exactly I will try to insist the other process is, let the child process wait until the parent process completes its task. Okay, like that same here in this case, if the currently running process is a child process, let the parent process wait until its child process. That is how we can able to achieve the synchronization between the parent process and child process. So in your main exam, if you have been asked to represent a race condition, a small code snippet of a race condition, you need to write this entire small code program. and if they ask you to write another program for a race avoidance of a race condition, all you need to do is write the same program and try to add two more functions called wait parent and wait child, which are being used to synchronize between a parent process and then the child process. So that is about the race condition for in today's session. Thank you.